Find all functions g of x such that the second derivative of x equals 3x squared plus 2. Well, this is interesting. We need to figure out which functions have a second derivative that's given. So to do that, we've got to take two antiderivatives. The opposite of differentiating twice is antidifferentiating twice. So let's start by antidifferentiating once. If we antidifferentiate once, that will give us g prime of x. Because when you take the antiderivative of the second derivative, you drop down to the first derivative. So we need the antiderivative of this. The antiderivative of x squared, we know that we increase the exponent by 1 and then divide by that exponent. So I'm going to keep the 3 out front. The antiderivative of x squared is x cubed over 3. And we notice that those 3's are going to cancel. So we're just going to be left with x cubed. And then plus, what is the antiderivative of a constant? What has a derivative of 2? Well, if we think a little bit, we remember that a linear function has a derivative that's constant. And so, if we think of 2x as a function, the derivative of 2x is just 2. And so that is what we have here. So we basically have x cubed plus 2x. But remember, when we take the antiderivative, we need a constant, so that's plus c. So that is our g prime of x. That is our first antiderivative. But to get to g of x, we need to antidifferentiate again. So let's give that a go, term by term. We have the power rule here that says that we increase the power by 1 and divide by the new power. So the antiderivative of x cubed is going to be x to the 4th over 4 plus the antiderivative of 2x. I think you know which function has a derivative of 2x. That is x squared. Plus, now here's an interesting thing. We need the antiderivative of this constant. But we saw earlier the antiderivative of a constant is just that constant times x. So the antiderivative of c is going to be cx. And then plus, we are taking an antiderivative. We need a constant, but we can't call it c because we've already used c. So let's use d for another constant. We could have called them c sub 1 and c sub 2, but I'm just going to use c and d. It's fine either way. And so we have our final answer, x to the 4th over 4 plus x squared plus cx plus d. Let's check and make sure that that works. So we've got our function g of x. Let's differentiate the first time to get g prime. The derivative of x to the 4th is 4x cubed. So we've got 4x cubed over 4. Plus the derivative of x squared is 2x. The derivative of a constant times x is just that constant. And then the derivative of a constant term on its own goes away. That's 0. So that's gone. And if we cancel out the 4's in that first term, we've got x cubed plus 2x plus c. And if we take the derivative of that, the derivative of x cubed is 3x squared, plus the derivative of 2x is 2. And that is exactly what we started with. So we're good to go.